want to show you how we prove the sum of the squares of the natural numbers from r equals 1 to r equals n. We've already done the sum of the ones and the sum of the natural numbers, sum of r. The next one we need to do is this one, and I want to show you the reason the formula is what it is. So, as I said, we already know that this adds up to n, and this one adds up to a half n plus 1. Notice that this one is order of 1 for n, and this one will have an order of 2. If we multiplied out this, we'd have a quadratic order, so the order of that one is 2. It would make sense then that the order of this one is going to be some sort of cubic, so it's going to be of the form an cubed plus bn squared plus cn plus d. We can work out a, b, c and d, and that's what I'm going to do with you. So the first thing we need to think about, we need to get 4 equations. We need to know 4 equations because we've got 4 unknowns. And what we can do is we can look at what happens when n is 1, 2, 3 and 4 and form some equations. So when n is equal to 1, what happens? Well, we'll be finding the sum from r equals 1 to 1 of r squared. So that's just going to be when r equals 1, we're going to get 1 squared, which is just 1. And that's the only term that's going to be in that sequence because we're only going from when r equals 1 up to 1. When n equals 2, we're going to be going from r equals 1 to r equals 2 for r squared. And that's going to be 1 squared add 2 squared, which is going to be 1 add 4, which is 5. When r equals 3, we're going to have the sum of 1 to 3 of r squared, which is going to be 1 squared add 2 squared add 3 squared, which is going to become 9 add 5 is 14. And we'll do one more when r is, sorry, this should say n. When n is 4, we get 1 squared plus 2 squared plus 3 squared plus 4 squared this time, which is going to be 14 add 16, so 30. If we link that to this equation now as well for each of these, we're going to have that when n is 1, we're just going to have a plus b plus c plus d. A times 1 squared plus, cubed, b times 1 squared plus c times 1 plus d. So that's going to be equal to a plus c, b plus c plus d. When n is 2, we're going to have 2 cubed is 8, so we're going to have 8a plus, we're going to have 2 squared, so 4b. We're going to have 2c, and we're going to have d again. When n is 3, we're going to have 3 cubed, which is 27, so 27a. We're going to have 3 squared, which is 9, so 9b. We're going to have 3c and d. And when n is 4, we're going to have 64a plus 16b plus 4c plus d. And so if you look here, we've created four equations for 4 unknowns. That's why I've done it 4 times. We've got 4 equations, 4 unknowns. And we can solve these equations. We've got a set of simultaneous equations. There happens to be 4 unknowns, which is quite annoying. It's going to take quite a while to work these out, but we can do it. I'll write them out again. A plus B plus C plus D is 1. 8A plus 4B plus 2C plus D is 5. 27A plus 9B plus 3C plus D is 14. And 64A plus 16B plus 4C plus D is 30. So, how do we solve 4-dimensional simultaneous equations? Well, we use the same principles of substitution, of elimination, as we do for 2 simultaneous equations. We try and eliminate letters from rows. The easiest one to eliminate is going to be D. If I subtract row 1, if I call this row 1, if I subtract row 1 from row 2, 3 and 4, that will create us a new set of simultaneous equations, but D won't be in those equations because D will cancel, D will be eliminated. So if I subtract row 2, if I do row 2 minus row 1, that's going to give me 7A plus 3B plus C is equal to 4. If I do 3, take away row 1, I'll get 26, that's a 6, 26A plus 8B plus 2C is 13. If I do the same thing for the 4th row, I'll get 63A plus 15B plus 3C is 29. Next job is we're going to try and eliminate C. Now, we could write down what this row is multiplied by 3. That's what we would do kind of lower down in lower years. But what we can do is just go straight into, if I now call this row 1, row 2 and row 3. So a new row 1, new row 2, new row 3. So for row 2 then, my new row 2, this one here, I'm going to need to do this row minus 2 of these. That will eliminate C. 2C minus 2C is going to be 0. So I need to do row 2 minus 2 lots of row 1. Okay, that's going to give me, so 26 minus 14A, because I need to take 2 lots of this row away to eliminate C, is going to be 26 minus 14 is 12A. I'm going to have 8A minus 2 lots of 3B, so minus 6B is going to be 2B. The C's are going to disappear. And I'm going to have, for what that's equal to, that's going to be equal to 13 minus 2 lots of 4, so 13 minus 8, which is 5. And this row, I'm going to need to take 3 lots away. So 63 minus 21A is going to be, 63 minus 21 is 42A. And 15B minus 12B is going to give me 3B. And that's going to equal 29 minus, sorry, not 12, that needs to be 3 lots of this, so minus 9B is going to be 6B there. And 29 minus 4 lots of 3 is 29 minus 12, which is going to give me 17. So you can see here, now I've got a 2-dimensional pair of simultaneous equations, which we should all know how to solve. So I can do one more lot. I can take away 3 lots of this row from here. So I'm going to do row 2 minus 3 lots of row 1, if this is my new row 1 and new row 2. So 42 minus 3 lots of 12, 42 minus 36 is going to be 6A the b's are going to cancel. 6b minus 6b is going to be 0. And I need to do 17 minus 15 is going to be 2. So a is 2 over 6, which is a third. Now the good thing about this, the way we've set these up is now each time we go back a step, I can just substitute this value for a in, so say into here and get b. I've then got a and b. I can take those and put those into here to get c, and I can take those and put those into here to get d. So the last part of this is quite quick. We know that 12a plus 2b is 5, but a is a third. So 2b is going to be equal to 1, so b is a half. I can take the fact that a is a third and b is a half, and as I said before, I can then put those into the 7a plus 3b plus c equals 4. So 7a is going to be 7 thirds. It was 3b, so that's 3 halves, plus c is equal to 4. That's going to give me c being equal to, that's 24 over 6 minus, this will be the 6th, 21 over 6, and no, it won't, that might be 21 over 6, that will be 14 over 6, sorry. 14 over 6, and this will be 9 over 6, so that's 23 over 6. So C is a third, sorry, a sixth. C is a sixth. So we've got A is a third, B is a half, C is a sixth, and then the last step we need to do is we need to find D. We had that A plus B plus C plus D was equal to 1. So we've got a third plus a half plus a sixth plus D is equal to 1. If you add these together, we actually get 1. So D is 0. So all that means is that the sum of the squares of the natural numbers from 1 to n is going to be equal to an cubed. A was a third, so a third n cubed plus a half for B, a half n squared plus a sixth of n. D was 0, so that's it. We can simplify this, we can write this more neatly. I can take out, like I've done in lessons, I can change this to 2/6 and this to 3/6 so that I can take out a factor of a sixth n and get 2n squared plus 3n plus 1. This factorises as well. So 2n and n, it's going to be 2 1s. So that's my final simplification. The sum of the squares of the natural numbers from 1 to n is a sixth n bracket n plus 1, 2n plus 1. And that's what we're going to use in lessons. So I just wanted to show you where this comes from rather than just give it you in class. But I didn't want to go through this in class because it's going to take too long.